What happens when a star the size of Jupiter goes rogue? Betelgeuse, one of the brightest stars in our night sky, is experiencing a mysterious transformation that has astronomers puzzled and excited. Imagine a star so colossal that it would dwarf our Sun and engulf all the planets up to Jupiter if placed at the center of our solar system. This behemoth is Betelgeuse, a red supergiant star located in the constellation Orion. For centuries, Betelgeuse has been a celestial wonder, captivating stargazers with its striking reddish hue and immense size. But now, this cosmic giant is behaving strangely, leaving astronomers on the edge of their seats. In a stunning twist, Betelgeuse has recently experienced a sudden increase in brightness, surging by over 50% and leaping from the 10th to the 7th brightest star in the night sky. This dramatic change has left scientists baffled and eager to unravel the mystery behind Betelgeuse's transformation. What could be causing this remarkable behavior? Is Betelgeuse on the brink of a cataclysmic event, or is this just a temporary phase in the star's life cycle? To understand the significance of Betelgeuse's strange conduct, we must delve into the factors that contribute to a star's brightness. A star's luminosity is determined by its size, temperature, and distance from Earth. Betelgeuse is a true giant among stars, with a radius more than 700 times that of our Sun. Despite its enormous size, Betelgeuse is relatively cool for a star, with surface temperatures ranging between 3000 and 3500 K, which gives it its distinctive red color. Throughout history, ancient civilizations have been fascinated by Betelgeuse and have woven the star into their mythologies and folklore. The ancient Egyptians associated Betelgeuse with the god Osiris, the ruler of the underworld, while the Greeks linked the star to the legendary hero Orion. These stories serve as a testament to the enduring aura of this celestial marvel. As astronomers continue to observe Betelgeuse's puzzling behavior, they are left with burning questions about the star's future. The stakes are high, and the consequences could be nothing short of astronomical. If Betelgeuse is indeed on the verge of a supernova explosion, it would be a once-in-a-lifetime event that could illuminate the night sky like never before. The explosion would be so bright that it would be visible even during the day, casting shadows on Earth and providing an unprecedented opportunity for scientific study. But the question remains, is this the calm before the cosmic storm, or simply a temporary fluke in the life of a stellar giant? It's essential to understand the star's immense size and its current stage in the stellar life cycle. Betelgeuse is a red supergiant, a type of star nearing the end of its life. Stars, like living organisms, are born, evolve, and eventually die. They begin their lives in nebulae, vast clouds of gas and dust, where gravity pulls material together to form protostars. As these protostars gain mass and temperature, nuclear fusion ignites in their cores, marking the birth of a new star. Over millions or billions of years, stars like Betelgeuse burn through their nuclear fuel, fusing hydrogen into helium and then helium into heavier elements. As they age, the internal dynamics of these stars change, leading to a series of transformations. When a star with a mass similar to Betelgeuse's exhausts its fuel, it expands to an enormous size, becoming a red supergiant. At this stage, the star's outer layers are barely held together by gravity, making it highly unstable. The fate of a red supergiant like Betelgeuse is to eventually collapse under its own immense weight and explode in a spectacular cosmic event known as a supernova. Supernovae are among the most powerful and luminous events in the universe, releasing an enormous amount of energy in a short period. Betelgeuse is destined for a Type II supernova, which occurs when a massive star exhausts its nuclear fuel and can no longer support its own mass. The core of the star collapses, triggering a shock wave that tears the star apart, expelling its outer layers into space at incredible speeds. If Betelgeuse were to go supernova, it would be a sight unlike any other. The first sign of the impending explosion would be a massive flood of neutrinos, elusive subatomic particles that rarely interact with matter. These neutrinos would escape the star's core moments before the shockwave, arriving at Earth hours before the light from the supernova. Observatories around the world would be crucial in detecting this neutrino burst, alerting astronomers to the imminent supernova. As the shockwave reaches Betelgeuse's surface and the star explodes, an enormous amount of energy would be released in the form of light, heat, and other radiation. The supernova would quickly brighten, becoming visible to the naked eye on Earth even during the day. At its peak, the exploding star could outshine the full moon, casting shadows and turning night into day for several weeks. The excitement surrounding Betelgeuse's potential supernova is palpable among astronomers. As Dr. Emily Thompson from the University of California, Berkeley, puts it, Betelgeuse is a ticking time bomb, and we have the privilege of witnessing its final moments? A supernova of this magnitude would be a once-in-a-lifetime event, providing an unprecedented opportunity to study the death of a massive star in real time. It would be a scientific goldmine, offering insights into stellar evolution, nuclear physics, and the chemical enrichment of the universe. However, the story of Betelgeuse took an unexpected turn in late 2019 when the star suddenly began to dim instead of continuing its dramatic brightening. This dimming was so significant that it was noticeable even to the naked eye, with Betelgeuse fading to about 40% of its usual brightness. The astronomical community was puzzled by this sudden change and scrambled to observe the star more closely, hoping to unravel the cause behind its fading light. The dimming of Betelgeuse poses a fascinating challenge for astronomers. Is this a sign of an impending supernova, or is there another explanation for the star's unusual behavior? The mystery deepens as we consider the possibilities, and the anticipation builds as we await further observation and data. But the story of Betelgeuse is far from over. The fate of this enigmatic star holds the key to understanding the very nature of the universe and our place within it. Betelgeuse continues to captivate astronomers as its unusual behavior sparks a flurry of new theories and observations, with the red supergiant star refusing to follow the script. Scientists are racing against time to solve the puzzle before the cosmic drama reaches its climax. The Very Large Telescope (VLT), in Chile, one of the most advanced observatories in the world, managed to capture a series of images that would prove crucial in understanding the star's behavior. The VLT images revealed that Betelgeuse's appearance was far from symmetric. The star, which had once appeared as a uniform disk, now had a distinctly lopsided shape. It was as if a cosmic hand had reached out and squashed the star, leaving it misshapen and distorted. But the asymmetry was just the beginning. As astronomers analyzed the data, they discovered the presence of a huge shock in our line of sight. This shock, unlike anything they had seen before, seemed to be emanating from the star's surface, suggesting that something truly extraordinary was happening on Betelgeuse. To understand the significance of these findings, we need to delve into the concept of a photosphere. A star's photosphere is essentially its visible surface, the layer from which light is emitted into space. In the case of Betelgeuse, astronomers had long assumed that the star's photosphere was relatively stable, with only minor fluctuations over time. However, the VLT images told a different story. They revealed that Betelgeuse's photosphere had started to expand, causing the star to appear larger than ever before. It was as if the star was slowly swelling up like a cosmic balloon being inflated by an unseen force. As astronomers raced to make sense of these observations, they discovered two more anomalies that would shed light on the star's behavior. In mid-November 2019, just as Betelgeuse was reaching the peak of its dimming event, they noticed the appearance of a dark southern hemisphere on the star's surface. This region, which had previously been as bright as the rest of the star, was now significantly darker, suggesting that something had caused a major change in the star's appearance. At the same time, astronomers detected a significant drop in Betelgeuse's surface temperature. The star, which typically burns at around 3,500 degrees Celsius (6,332 degrees Fahrenheit), had cooled by several hundred degrees in just a few months. This rapid temperature change is highly unusual for a star like Betelgeuse and suggests that some kind of sudden, dramatic event took place on the star's surface. To understand why this temperature drop is so strange, we need to consider the nature of red supergiant stars like Betelgeuse. These massive stars are in the late stages of their lives, having exhausted the hydrogen fuel in their cores and begun to fuse heavier elements. As a result, they have expanded to enormous sizes, with radii that can be hundreds or even thousands of times larger than our Sun. Despite their gigantic size, red supergiants are actually cooler than smaller, younger stars like our Sun. This is because their expanded atmospheres allow more of their energy to escape into space, leading to lower surface temperatures. However, these temperature changes typically occur very slowly, over timescales of years or even decades. The fact that Betelgeuse's temperature dropped so quickly and by such a significant amount is therefore highly unusual. It suggests that some kind of major upheaval occurred on the star's surface, one that disrupted its normal temperature regulation mechanisms. As the evidence mounted, astronomers began to converge on a shocking conclusion. Betelgeuse had likely experienced a massive surface mass ejection, SME. SMEs are powerful eruptions that occur when a star ejects a significant portion of its mass into space. While SMEs had been theorized for decades, no one had ever directly observed one on a star like Betelgeuse. The implications of this discovery were staggering. If Betelgeuse had indeed experienced an SME, It meant that the star was even more unstable than previously thought. It raised questions about the star's future and whether it might be approaching the end of its life. But the SME also presented an incredible opportunity for astronomers. By studying this unprecedented event in real time, they could gain new insights into the inner workings of massive stars and the processes that govern their evolution. The massive surface mass ejection that Betelgeuse experienced can be likened to a star-sized volcanic eruption of epic proportions. Imagine a celestial giant, a star so colossal that it dwarfs our Sun, suddenly expelling a tremendous amount of material from its surface. This cosmic eruption sends shock waves rippling through the surrounding space, creating a massive plume of gas molecules and dust that partially obscures our view of the star. The scale of Betelgeuse's SME is truly mind-boggling. Astronomers estimate that the star ejected a staggering 400 billion times more mass than a typical event on other stars. To put that into perspective, the amount of material thrown off by Betelgeuse is equivalent to multiple times the mass of Earth's moon. If you were to gather all that ejected mass and shape it into a mountain, it would make Mount Everest look like a mere pebble in comparison. To further illustrate the incredible scale of this event, consider this. If you took all the water in Earth's oceans and converted it into gas, it would still be a drop in the bucket compared to the volume of material that Betelgeuse expelled into space. The SME was a cosmic spectacle of unimaginable proportions, a testament to the raw power and majesty of the universe. But it wasn't just a visual spectacle, it also had a profound impact on Betelgeuse itself. The star lost a significant amount of mass during the event, which in turn altered its pulsation period. Before the SME, Betelgeuse's surface expanded and contracted on a regular 400-day cycle. However, after the ejection, that period was cut in half to just 200 days. Changes in a star's pulsation period can have far-reaching consequences for its stability and longevity. Pulsations are like the heartbeat of a star, and when that rhythm is disrupted, it can be a sign that the star is entering a new phase of its life. For Betelgeuse, the altered pulsation period suggests that the star may be one step closer to its ultimate fate, a spectacular supernova explosion. To better understand the cause of Betelgeuse's SME, astronomers turned to cutting-edge scientific simulations. Using complex algorithms and powerful supercomputers, researchers created detailed models of the star's interior, simulating the intricate physical processes that govern its behavior. These simulations revealed that an unusually hot current of gas, like a massive searing bubble, rose from deep within Betelgeuse and burst through its surface, triggering the ejection of material. The simulations employed by astronomers are marvels of modern science. They incorporate a wide range of variables and parameters, from the star's temperature and density to its magnetic field and rotation rate. By feeding in data from state-of-the-art telescopes like the Very Large Telescope (VLT) and the Hubble Space Telescope, scientists can create a virtual replica of Betelgeuse, a digital twin that allows them to study the star in unprecedented detail. With the clock ticking down to Betelgeuse's inevitable supernova, astronomers are employing cutting-edge technologies and innovative strategies to unlock the star's secrets before it's too late. Please like and subscribe the channel.